We're going to have a look at sequences now. You basically have nth term, linear nth term or quadratic nth term. If it's an ordinary linear nth term, you find out what it's going up in. It's going up in 1.5s. So that means 1.5n. Now n stands for number 1, number 2, number 3. So if you put in 1.5 times 1, you get 1.5. You want the answer to be 2, so you have to add 0.5 to it. Just check, does that work? 1.5 times 2 is 3. Add 0.5 is 3.5. So it works. And just check it for your third term here. 1.5 times 3 is 4.5. Add your 0.5 gives you 5. I'm going to see it again here. So this is going down in minus 5s. So it's consistent the whole time. So your formula starts off minus 5 times n. Again, n is number 1, number 2, number 3, number 4. Minus 5 times 1 is minus 5. To get 100, you have to add 105 to it. Check, does it work? Minus 5 times 2 is minus 10. Minus 10 add 105 does give you 95. The quadratic ones have a bit more work. Have a look now at the quadratic nth term. You'll recognise the quadratic nth term because when you start to do the differences, you will see they are not consistent. So it's not the same number going up each time, whereas in the linear nth term, it is the same number going up each time. So you have to go to the second difference, which is 2. Once you're into the second difference, your formula will start off with half that number, half of 2 is 1, times n squared. Now, it's quite nice to have write out your n squareds, as in 1 squared, 2 squared, 3 squared, 4 squared. Now, if you look at your squared numbers and you look at your pattern, you will see for the first term there is no difference. For the second term, you have to take away 1. For the third term, you have to take away 2. For the fourth term, it's a 16, you want it to be a 13, you take away 3. What I now need to do is I need to find the nth term of these numbers here. It's going down with 1 each time. So you write minus 1 times n. For number 1, minus 1. I want it to be a 0, so I add 1. Does that work? Check in number 2. Minus 2, add 1 gives me minus 1. Check for number 3. Minus 3, add 1 does give me minus 2. So your final answer for the nth term here is the first part of your formula, add the second part. We'll do another one of those. So you've got 4 to 5 is add 1. 5 to 4 is take away 1. 4 to 1 is take away 3. 1 to minus 4 is take away 5. Minus 4 to minus 11 is take away 7. You will see these numbers are not all consistent, so we have to go for the second difference. The difference here is take away 2. The difference here is take away 2. So it's take away 2 each time. Because we're into the second difference, our formula starts off with that number divided by 2. So it's minus 1n squared. And again, it's nice to work out your minus n squared. Minus 1 squared, minus 2 squared, minus 3 squared, minus 4 squared. Now, if you take these numbers and see what you have to do to get your pattern. Minus 1 needs to be a 4, so I have to add 5. Minus 4 has to be a 5, so I need to add 9. Minus 9 has to be a 4, so I have to add 13. And minus 16 has to be a 1, so I've got to add in there 17. And I need the nth term of these numbers. It's going up in a 4. That's consistent, so it's just 4n. 4 times 1 is 4. I want it to be 5, so you add 1. Does it work? 4 times 2 is 8, add 1, 9. So that works. So pulling it together, the nth term is the first part of the formula plus that part of the formula. Now, Sometimes you can have problem questions in this. So the one I'm looking at here is which term of that sequence 2, 8, 14, 20, 26 will equal 98. So I've got to find the nth term. So that's going up in a 6, a 6, a 6, and a 6. So it's a wee linear one because it's all the same. So 6 times n, remember n's number 1. So 6 times 1 is 6. You want it to be 2, so you take away 4. Does that work? 6 times 2 is 12, take away 4. Now, that's perfect. You want that to equal 98. Solve the wee linear equation, bring that across, add it on. So it becomes 102. And then you're going to divide by 6. So 6 into 10 goes once, was 4 over, and 6 into 42 goes 17 times. And another one. Find the 100th term of a sequence whose third term is 8. So just going to write this out. First, second, the third term is 8. The fourth term is 11. And the fifth term is 14. And the sixth term is 17. I'm going to work out the nth term here first of all before we start. So it's going up in threes. So it's 3 times n. And just be careful because you're starting off at the third term there. So your n's going to be 3 for the first one. 3 times 3 is 9. To get 8, you take away 1. Does it work? 3 times 4 is 12. Take away 1 gives you 11. It does indeed. So let's read the question again. So find the 100th term of that sequence. So you want 3 times 100 to take away 1. 300 take away 1. 299.